And I'm showing that it is now 1 o'clock Eastern, and I see the recording is already going. So I'm going to go ahead and kick us off, and we'll know that there will be folks who will inevitably call in over the course of the next couple of minutes. But the person that you're listening to right now is Katherine Skinner. I am one of the 2 PIs on the BitCurator.edu project, which is hosting this particular webinar. And I am just wanting to thank you guys as we get started for being here and for participating in this webinar. The purpose of the BitCurator.edu project, which is a partnership between the University of North Carolina at Chapel Hill's School of Information and Library Science and the Educopia Institute, along with the BitCurator Consortium and the Council of State Archivists, is for us to basically study and advance the adoption of digital forensics tools and methods in libraries and archives. And we're doing this through both continuing education and iSchool and schools of library and information science programs. So we have 2 main research questions that we're dealing with in the context of this particular project. And those are, we're looking at what are the primary institutional and technological factors that influence the adoption of digital forensics tools and methods in LIS classrooms, and how do those vary according to different educational settings. And then we're also looking at what the most viable mechanisms are for sustaining collaboration among LIS programs on adopting digital forensics tools and methods. So as Cal Lee, who is the lead PI on this project and who will be leading the webinar in just a moment, as he will share, both Cal and I have known for years in our collaboration that one of the liabilities in LIS programs and also in continuing education programs around library science and archival science is that there aren't good support mechanisms in place, especially in virtual environments, but also increasingly in physical environments, for labs and for digital curation tools and technologies. And so once you're dealing with tools that, or environments that require students to download them and install them, especially if they're Linux-based or if they vary from, very simple and simplistic kinds of software, then you run into major problems as a professor or as a leader of those programs when you try to integrate those into the classroom. And so lowering the barrier to teaching digital forensics tools and methods requires us to take a good hard look at how LIS classrooms and, in both physical and virtual spaces can practically and without undue burden on both the professors and the students get the experience that they're looking for with digital curation technologies, and particularly here with digital forensics tools and methods. So with that as just a very, very quick background to this BitCurator.edu project, which is being funded by the Institute for Museum and Library Services, I will actually hand it over to the lead PI on the project and my co-PI on this and on several other projects, Cal Lee. So Cal, you want to take over?
Hello, yes, thank you. Thank you very much, Katherine. So I'm going to share my screen here, and what I'm going to do is give a presentation, which will provide some of the foundation to the BitCurator environment for those who might not be as familiar with all of the details, but also I thought it would be useful to set it within the context of the way that I and many others tend to teach this, to kind of give the motivation for the concepts that it demonstrates. And one of the reasons why I think so many educators have made, aside from the fact that it's free software you can download and run as a virtual machine, I think it also really demonstrates a lot of the concepts that become fundamental for making this mental shift from analog to digital materials. To set it further into context, we have a series of 3 of these webinars, which you're probably aware of, for BitCurator.edu. This one, which is really introduction to the environment, specifically for an audience of educators. The second one will be on BitCurator Access and BitCurator NLP, which is software that we have more recently developed within the team at SILS. And then finally, we have one that is catered to IT support and management staff within your schools or within your support structures. So the idea is to have an opportunity to have a much more detailed discussion with those who might have to administer this about what are the implications, what kind of footprint does it have, what sort of considerations should you be keeping in mind as you do those sort of things. And we did have a similar webinar to that for BitCurator Consortium members a couple of years ago, and I think it was very well received. So right now with my full screen, I won't necessarily do the best job of attending to questions that might come up in the chat, but please feel free to share them, and I'll get to them when I'm able. And also be aware that Katherine is on the call, but also Cam Woods is on the call, who knows a great deal about this environment as well. So he's not listed on the slide here because I'm the primary presenter, but if there are things that come up during Q&A that, that others might be able to weigh in on, just be aware they're also on the call. So a little bit of background to this. Again, Katherine said that this is a partnership between the School of Information and Library Science and Educopia. We've been doing work along these lines of trying to incorporate digital forensics into our educational offerings for about 8 years or so. And so this is kind of a next iteration of it that involves a lot more partners, and we're very excited about the possibilities. So the primary motivation for a lot of this, and again, what I'm trying to do is frame it how, you know, this is not prescriptive. People will have a lot of different ways to teach these things, but this is the way that you know, I and others in our circle often tend to convey these things. And is first to just start off with this idea of what are the goals when acquiring digital materials, right? Well, it's the same for acquiring any other kind of materials. Some of the primary considerations are ensuring integrity of the content, allowing users to make sense of it in terms of its context, so not just pulling out little discrete disembodied items, and also preventing inadvertent disclosure of sensitive data. And one thing that very much drives a lot of the educational offerings that, again, I've been providing, whether it's through our school, whether it's through the DAS curriculum of SAA, has been to bring it back to these fundamental archival principles, which I would argue aren't only relevant if you're working as a formally professional archivist, but also if you're responsible for, you know, aggregations of materials that you have to define as collections that are supposed to be evidence or traces of something. And so the first is provenance, that we want to reflect where something came from and the steps that it passed through. There's original order, which is being able to reflect not just where it came from and why it was created, but things like the organizational structure it sat inside of. What were the folders? What were the associations between different items? And then also chain of custody. And this is something that the digital forensics field itself takes very, very seriously. And, you know, archivists and librarians also tend to take as seriously as we can afford, which is to try to document the various steps that have been carried out in order to treat the material. So for example, the premise metadata standard is very much informed by this idea that you have different events in the life of an object that should be recorded. But digital materials are different, and many of you have probably heard some version of my spiel on these things, this idea that there are these different levels of representation that become really important because they are present at the same time and convey different kinds of information. So I'm not going to spend a great deal of time on this. What I want to do is frame it, as I suggested at the beginning, as the educational motivation, that part of the motivation for using this environment can be to demonstrate these kind of concepts. But that's not the exclusive motivation, because it could be you just want students to get some familiarity with some Linux tools, and this is a convenient way for them to do it, for example. But this idea of representation is very foundational, at least from my perspective, right? As Brian Cantwell-Smith tells us, we don't have computation without very, very detailed representation of precisely what the information is supposed to be, that then the computation is applied to. And these levels of representation then can be very helpful for framing this. There are aggregations of objects, objects or packages, in-application rendering, the file through the file system, file as a raw bit stream. I'm just listing them now, but then I'm going to elaborate in a little bit more detail. Subfile data structures, the bit stream through the input-output equipment, the raw signal stream, so even below the level of interpreting it as ones and zeros, the actual more physical properties of what's happening across the wire, and then the bit stream on the physical medium itself. So just to illustrate this a bit, these are a few of these things are an example from materials that the National Library of New Zealand talked with me about a number of years ago, these gazettes that the government produces. So at the highest level aggregation, you might be just looking at wanting to show some coherent arrangement of, you know, what series and numbers and items were they a part of, like this was an issue of the Gazette. But you could drill down into the level of looking at an item that has associated metadata with it, right? So it's an object that's not just a bit stream, but it's also not at that full aggregate level. You might be concerned about the in-application rendering, so how things are, sorry, I just saw that there were a couple chat items. The in-application rendering can be very important if you care about particular properties of how it gets represented. Okay, sorry, I was just seeing what the discussion was on the chat. The file through the file system is then, you know, if you've had any exposure to these digital forensics practices and some of this training or the software, the file system tends to be a very, very strong focus because it's the center of so much of this kind of provenance original order information. It has timestamps, it has the arrangement, where was this within the directory path. It has information about, in some cases, depending on the file system, what user account ID is associated with the files and various things like that. And we can encounter those either through the command line or through the graphic user interface that most of us tend to use. Another level, but looking at the raw bit stream, is in terms of bytes, right? So a hex dump is a hexadecimal representation, 0 up to 15. And the reason why that's a very convenient base to use, you know, 16 as opposed to some other number, is that if you use 2 of those characters next to each other, the 2 nibbles together, they make 1 byte worth of information, 256 possible values. And because so much information is represented as bytes in digital environments, it becomes a very convenient way to look deep inside of files or other data structures to figure out what's really going on inside of them. So in the BitCurator environment, which we're going to be bringing up in just a few minutes, you can go to scripts, file analysis, and then view in a hex editor. And you'll then see this representation that has on the left side the hex, right? These values from 00 up to FF. And then on the right side, what those things would be as characters if they're actually representable as ASCII text. Checksums are another thing that is very important in this space, and obviously in a lot of other situations. So generating this output from an algorithm that then can determine whether bits have changed in transfer, whether they've changed in storage, whether 2 files are identical even though they might be named differently. And so these can be very helpful to demonstrate in this environment. Another thing that I'm not planning to go into in any detail during this webinar, but I'd be happy to discuss with others later, is NSRL lookup. So this is something that at our more advanced forensics classes, we, for example, the DAS curriculum, we have the 2-day advanced sequence. One of the exercises we have the students do is use a tool called NSRL lookup, where they'll identify some files from their machine that are associated with an application, right? They'll go in and say, oh, here are all the files that got put into the Adobe Acrobat folder in my program files folder. And then they'll create hashes of those and run NSRL lookup to compare them to the National Software Reference Library to see whether they are known system files within that resource. So that can also be a really helpful way to demonstrate both kind of the motivation for doing something like that, but also the mechanics of it. So as I'm sure you'll all agree, having some motivation behind just having somebody type something at the command line can really help to motivate students to do it, right? Rather than like just practice typing obscure things at the command line. In the BitCurator environment, you can right-click on a file or directory and calculate MD5. Then you can either display it on screen or save it to a file. In this case, just for demonstration, it's shown on the screen. If this window were to be wider, you'd see the hash, a tab in between, and then the actual file name with its full path over to the right of it. And there's nothing special or magical about this software at all. For those of you who have used this software, you've probably used 5 or 10 different applications that all do this same thing, right? They generate a hash with a file name associated with it, and they just go line by line and put it into a text file. This is one of my favorite examples for demonstrating these notions of representation levels to students. This is a Microsoft Office file. So this is a, it could be a Word document or a PowerPoint presentation. And because these contemporary file formats that we use now are just zip files, by simply opening them in WinZip, 7-zip, whatever your application of choice is, you can then look inside and see these subfile data structures the way that it's actually laid out within that package, right? And I just think that educationally, this is really, really helpful for illustrating this primary concept, which is that these levels of representation don't mean different objects, right? You could take a Word document and open it in Word, you could open it in a hex editor, you could open it in WinZip. Every one of those are looking into it in a different way, but you're still interacting at some level with the same object, essentially, and certainly with the same bits at a lower level. There are also a lot of other subfile data structures that can be really useful to run through in classes to demonstrate different ideas. EXIF metadata is one of them. I'm not sure that there's quite the same eye-popping shock that there used to be a few years ago when presenting these things. I feel like, you know, in years past, when I pointed out to people that they had all these GPS coordinates embedded in images that they'd taken on their phones, everybody got pretty freaked out by it. Anecdotally, I feel like people are a bit more aware of that now, but it's still a really useful thing to point out to people, right? That there's this sort of what we might sometimes call hidden information that's embedded within the image, right? So if you were to just focus exclusively on what I've been calling the in-application rendering, and you say, oh, I've got a JPEG file, I convert it to PNG, I convert it to TIFF, who cares? The image looks pretty much the same, right? Without recognizing that there's this other metadata that's embedded inside of it. This is just to point out, which is also a very useful thing for students to be aware of, that if you get an image that has EXIF metadata embedded in it from a medium, right, off of a flash drive, a hard drive, that was owned and managed by the creator, him or herself, it's very likely to have much more rich metadata than if you were to go grab that from Facebook or other online sharing environment, because many of them strip out the metadata. So Facebook, for example, strips out the EXIF metadata that we were just looking at. This is compliments of Doug Reside, an example of fast save from a Word document where you could go in and see the changes that have been made based on the weirdness of the sort of 90s, early 2000s way that Microsoft Word tried to save time by fast saving rather than full saving the data. This is Geimager being used in the BitCurator environment. We'll bring this up when we go into the environment. There's metadata that you can assign. This is one of the stark reminders for people who are doing this in a more collecting institution kind of setting, right? Whether they're working professionals or they're library school students, that we're really borrowing the software from another environment, right? Because it says case number, evidence number, examiner. But as long as people are willing to make a minor translation in kind of what they map this to, then the software is still very powerful and useful. And we'll look at this a little bit more closely when we go into the environment, but it's creating a disk image, which is this kind of forensic representation of what was on the disk. There's then also the raw signal stream, which is even lower level. So using a cryoflux, for example, you can identify what the fluxes were on the disk as opposed to just what the ones and zeros are. And then finally, there's the surface itself, right? So I personally feel like a really important message to convey to students is that this notion that we often have that there's like physical records and then virtual or digital ones can be quite dangerous, because if we overlook the physical dependencies, then we risk not having any data at all, right? So you want to lift the information off the medium so that you no longer have to worry about it, but it means that going through that step of, you know, having the mechanical ability to represent the data, pulling it off the drive can be very important. And these are the levels in this levels of representation where a lot of the, at least from my perspective, applying the BitCurator environment in a class, for example, can really demonstrate these kind of middle layers of looking at disk images, looking at subfile data structures, looking at the file system the data is sitting inside of. And so I hope this helps to set the context a bit for what it's useful for and what it's probably not going to support a whole lot of, right? If you're looking at aggregations of objects and you're thinking of, you know, metadata structures and say archival description and things like that, there are a lot of things that have to be addressed in other ways because this environment really isn't addressing those. And similarly, if you were at a very, very low level of just looking at, like, let's look at how a hard drive works and what can go wrong and how you could lift the platter out in order to rehouse it if you had some issue, right? Those are all possibly interesting things to address in a class, but they're not really within the scope of the BitCurator environment itself. So 3 complicating factors: medium failure or bit rot, obsolescence, and volatility. So bit rot being that, you know, the bits won't be readable forever. A close cousin to bit rot is the fact that performance advantages of newer media, aerial density, input output speed, all those sorts of things make it just, you know, almost mandatory to move from one storage medium to another rather than relying on older ones. And so given all of those things, ensuring the integrity of the bit stream when moving from one place to another becomes really fundamentally important. And this, from my perspective, is another one of these very important conceptual contributions to bring into a class, is the idea that you shouldn't try to focus on the perfect storage medium, right? What you should be focusing on is how do I maintain the life of data as it moves from one storage environment to another. I believe I learned that first from Paul Conway, who I think is on this class, who is on this call. A class I took in digital preservation at the University of Michigan many, many years ago. Ted Nelson tells obsolete power corrupts obsoletely, right? These layers will be changing at different rates. And so this is something that, of course, is not new to the discussion around digital preservation. But one of the things that using forensic software can really help us with is if there's one of the layers that's broken or not available to you, you might be able to play at another level, right? So if you can't read the file system on a disk, you plug it in and you can't mount it, if you can operate at that lower level of the underlying bit stream, you can still create a disk image of it, right? So students being aware that these different levels are actually there can really help them with determining what strategy they should be using given what's actually available for the technology that they have. So the order of volatility is that some types of data change much more quickly and often than others. We have, you know, all the way up from like the registers in the CPU all the way down to, you know, long-term offline storage, tapes and things like that. And so, you know, the financial model is very different for those different types of storage. The performance is very different. And it also means that if you aren't careful, you can overwrite data that's at those much higher, more volatile levels of the stack. So a classic example of this is the browser cache. If you wanted to know somebody's browsing behavior, you would want to be cautious to grab that cache file and set it aside before you actually opened their browser and started investigating, because your act of using the browser would then start overwriting the cache. So the file system is this essential layer for metadata. It has access controls, file names and identifiers, file size, where to find the files in storage, right? So there's this indirection where a program doesn't make a call to a spot in storage, it makes a call to a name of a file that then gets routed through the file system to where it actually is in storage. And the timestamps are really fundamental, so that, let's say, for example, someone decides not to retain a disk image that has all the underlying file system information, but they want to run some of the tools that we're about to look at, like FiWalk, that can export that timestamp information into a separate file so that it doesn't get lost. Because those timestamps are some of the metadata that's most notoriously brittle. It's very easy to stomp on a timestamp inadvertently, and now all the access dates are different, or you know, created, for example, is when it was written to a particular storage medium. So when you're moving files around, the created date can be altered. So modified is when the content was last altered. Accessed is when software or a person in any form touched the file and made that update. Changed is when just the metadata as opposed to the underlying content is changed. And then created is this odd one that kind of comes out of the Microsoft world originally of when it was actually written to the storage medium itself. And if you're trying to show students where the file system is and you aren't accustomed to doing this, it's basically going to properties, right? So in Windows, you would go to the disk. Right here, you see this C drive. If you were to right-click on it and go to properties, you can see where it says it's an NTFS file system, which still is the most predominant file system in a Windows environment, though that's subject to change also. This is HFS+, which for a number of years was the predominant file system in a Macintosh environment. And now what we're seeing is APFS, which is still very much in flux. It's driving digital forensics professionals crazy because it's not as well documented as they would like, and it's still, you know, kind of undergoing revision. But one of the things to be aware of if you haven't done much teaching around these things is that many students tend to use Macs. And so it's important to show examples of Macs if that's the computer that's sitting in front of them. But it's important to be aware that the majority of the tools for doing digital forensics are created either for a Linux, kind of the open source Linux environment, or for Windows. There are some tools that run on Macs, but it's kind of the abandoned stepchild of the forensics world, right? They kind of, the market is basically driven by predominantly Windows platforms, and then some of these more kind of open source tools that run in a Linux environment, which we'll be looking at in the BitCurator environment. In the Ubuntu Linux environment of BitCurator itself, you can see this is an ext4 file system. So these are the places where you can identify what the file systems are. This is a fairly lengthy set of possible file systems you might encounter, but the ones that are most likely to come up, and they're therefore presumably most important to be covering in classes, are the various versions of FAT, which stands for File Allocation Table, NTFS, which is the default file system for the actual operating system on a Windows machine or on larger media where they need that file system for bigger files or bigger storage volumes. Then HFS, HFS Plus, and APFS are that's the kind of evolution of the file systems in a Mac environment. Before that even was MFS, which is the one you see above there. That's not as widely represented in collections, but it's also a good one to be aware of. And then the ISO 9660 file system, where you'll see ISO disk images that come from CDs. So this is just demonstrating in a Unix environment, this indirection that we have in the file system. You have the file name and then the inode, the number that represents it, and then that inode is associated with what's basically just a block of metadata that points out to storage as well, right? And this is referring to them as data blocks. In a Windows environment, we tend to call them clusters. That's the place out in storage where the file's contents actually are. So just very briefly about the Microsoft file systems. Again, the motivation for this, I can say that I tend to place a lot more emphasis on FAT and NTFS than any other file systems when doing education, just because those are still very much predominantly going to be the main file systems that people encounter when they're dealing with digital collections, though obviously not exclusively so. So FAT is supported very widely by different operating systems. It's common in a lot of removable media, thumb drives, memory cards, things like that. The way that it works is basically a boot sector. You have a file allocation table that has these different possible values. It either points to another place in the file allocation table. It says, I'm the end of the file, right? So read up to that point and then don't read any other clusters. Or it has an indication that it's available, right? It's an unallocated space in the file allocation table. So what happens when files are deleted is that basically the directory entry gets changed. This E5 hex value overwrites the beginning of the file name, and then the operating system knows to mask that from users from then forward. So unless you're using forensic software, you won't see all these directory entries that are on the drive that were previously allocated files, might still have some content associated with them, but are then essentially hidden away. And so then if something is deleted, all the different areas of the file allocation table associated with that file need to be marked as free. And this means that there can be a lot of residual data left over from the file before anything comes in and overwrites it. And this is really the primary use case for what forensics professionals call carving, where you go in and pull information out of those parts of the drive. NTFS is a little bit different in that it combines that kind of directory and file allocation functionality into what's called a master file table. What's good for forensic discovery is that for very small files, things that are just, say, a few characters, they're actually stored inside of the master file table itself. What's not so good for forensic discovery in terms of recovering information is that there is nothing like that set of residual directory entries that are left behind that you'd have on a FAT drive. Instead, you just have the overwriting of the master file table record when it needs to be used again. So if it's entry number 5000 and now another file comes along and needs to have an entry, it will overwrite it and there's no trace essentially left behind of the previous entry. There are different changes that students can make to their machines in order to see some more of these things. And this depends a whole lot on where they are, right? If it's continuing education and they're in a work environment in which their machines are completely locked down, then you might have to tell them, try this at home, right? But if they're students using their own laptops that they just bought at Best Buy or something, there's a good chance that they can make these changes. And they're essentially unearthing hidden things, right? So you can go in and view the folder and search options and make hidden files or folders visible. You can go into the hide protected operating system files. This becomes particularly important if you're demonstrating things like the Windows registry. If you want students to be able to go into the config, the places where you can see those files, SAM security, the files that are associated with the registry, those will be invisible to them unless they make this change on their operating system. Write blockers are another thing that can be important to address in class, though the question of whether you can do it with the hardware depends a lot on how you're administering things in the class. So a write blocker is a one-way street for data. It ensures that you can't write to the medium in any way, but you can read from it. The most secure way to do this is with a dedicated write blocker. A little bit less secure, but generally reliable, is write blocking tabs if they're built into the medium itself. And then finally, software-based mechanisms, which are questionable in many of settings and have a lot of caveats associated with them, because, for example, the operating system might decide with the latest patch to go in and overwrite your preferences because the operating system really thinks you want to be able to write to all the media. And so, there are a lot of different ways to demonstrate these things. It can be like I am here now with just pictures, right? So you can demonstrate the FRED distributed by Digital Intelligence that has this UltraBay thing at the top. What we're showing here is both the legacy ports from a kind of older FRED and then a newer one that has a different way of connecting things. The ones below that are a Tableau and a WeBTech write blocker. So they're smaller, more customized for particular kinds of ports and connectors. In our classes, when it's a full-blown dedicated digital forensics class, we bring out a bunch of these Tableau and WeBTech write blockers that we have purchased for this reason, and we hand them around the room, and people can try using them. It's not really rocket surgery to use a write blocker. It's important to use it in the right way, but I think there's a lot of educational value in just kind of talking through them as well. But I do think it can be beneficial to have at least one on hand to show people so that it doesn't seem like a complete abstraction. You can give them a sense of how these things work. So a 5 1/4 inch floppy, if light can get through, it's not write protected. So think of the classic example of getting a CD, a floppy disk in the back of a magazine, and you wanted to then use it as your own disk rather than reading the software off of it that was distributed to you. You'd have to peel that little label off so that you could actually write to the disk. And the 3 1/2 inch floppies are the opposite. If light can get through, it is write protected, so making sure that that little window is slid open. Example of software-based protection, and even calling it write blocking is a little bit deceptive. It's basically just a utility that we have built into the BitCurator environment that will ensure that mounted devices are set to read only by default. That default needs to be set by you because the default is not to be read only for reasons that we can describe to you if you really care, but based on issues people have been having with dual boot environments where they're using the BitCurator environment. In order to alleviate those issues, we made it not turned on by default, but you can go into this little icon at the top there and change it to read only if you want that to be the global setting. Floppy disks, one of the issues is that 3 1/2 inch floppies can be read through USB. They're fairly ubiquitous still. You have to look a little bit to find them, but you can buy them on the open market. 5 1/4 inch disks, the problem is that you can't really hook them up to a modern computer, so you need some kind of adapter. But they work like a hard drive in that there's a magnetic surface that's spinning around inside of the enclosure. So many of you I know on the call have been exposed to these things. There are a variety of these different devices. They come and go. Some people have them and then they go off the market. I think it's probably fair to say that the FC5025, the one in the bottom left corner, is probably the most widely used in libraries and archives. You can get a sense of the scale of it because that's a USB there. It's a very small little card that just goes from that ribbon that would otherwise be attaching to the motherboard of a computer, but instead goes out through USB. Again, these are things that if you have them on hand and you're doing enough training in these areas, it can be really beneficial for students to be able to have some experience using them. But if not, I think at least kind of talking through what they are and the role they play can be very beneficial. Two other things that are very mundane but worth pointing out to people are power and cooling. So if you're using an internal device and now you've pulled it out of a computer, it needs to get power, and it could need this Molex or SATA connector, Molex if it's an older device. And similarly, because it expects to be inside of a computer, it expects to have a fan blowing on it. And if you just set it on a shelf and start imaging it, for example, it can let the blue smoke out, right? It can basically damage or destroy the drive. So disk images become a big part of this work that people do with the software. It's getting below the file system to go bit by bit through each sector of the drive and writing it out into a file. There DD, for students who have more of a technical background, they may very well be familiar with DD already because a lot of system administrators use it. They might not necessarily be as familiar with the more specialized tools that are used to either create forensic disk images or to do multi-pass data recovery. There are a lot of different disk imaging tools that are in the BitCurator environment that have been designed for problem cases, not when you can just very easily dump the data. So what is digital forensics? It's basically discovery of information from these various places, process of identifying, preserving, and analyzing the data, but for legal purposes, right? And that's the way in which it's generally framed, and it needs to be repurposed in various ways to be appropriate to collecting institutions, for example. Just a little bit about the industry for those who aren't aware. There are some major software providers who are listed here who have commercial products. I'm not aware of anybody currently in more iSchool kind of settings using EnCase for education. We used both FTK and EnCase early on when CAM first came to SILS and we were teaching these things. Our original support from the Mellon Foundation was for a small scale grant to use FTK and EnCase in our classes and kind of develop some documentation around that. They're both relatively expensive. They do have educational packages where you can get them licensed at a lower rate for multiple seats and things like that. The EnCase, in our experience, was more of a hassle to administer, and their tech support was a little bit less responsive. But both of them can be useful if you have the means to demonstrate in classes, because they do have functionality that's not necessarily the same as the open source tools. A really fundamental difference between the primary forensic package, FTK, EnCase, also Autopsy, which is an open source alternative to these suites, is they're built on this notion of a case, which is a database. You create a case, which is just constructing an underlying database, and then every bit of evidence that you add gets pulled into that case. And they're traditionally based on this very heavy-duty pre-processing model where you run all of these different analytics on top of the evidence items so that then you can analyze them in a lot of interesting ways. And that can be really beneficial if it's at the right place in somebody's workflow. But one thing it doesn't necessarily give you as easily as some of the things in the BitCurator environment is that more quick characterization and triage. So one of the primary motivators for designing the environment the way we did is to make it essentially a toolbox that people can use in different combinations depending on what they're doing in their workflows. And one of the things we want them to be able to do very, very quickly is characterize and identify just what's there. Like, what kind of files are on this disk? Does it have any sensitivities? You could do that with FTK or with EnCase, but it's likely that getting to that initial assessment of what's there would be more time consuming because it's doing more of this pre-processing. That's not completely true in the sense that you could also customize how you're using those tools to have a more, for example, FTK has field mode where it does less of the analysis up front. And you can find a lot of information about open source tools at this forensics wiki, which was originally kind of owned and administered by Simpson Garfinkel. It's now more collectively administered, but it has a lot of really good information. So using digital forensics to advance data curation goals, use of write blockers, generation of disk images, applying cryptographic hashes to files, capturing DFXML, which is something we'll look at in just a few minutes, and scanning bit streams for personally identifiable information, right? And so I would say that it's been quite striking to see this transition from, say, 10 years ago, how much a lot of archives are now doing these things. And that's presumably one of the primary motivations for including these things in education too, right? Both that it exposes people to these kind of concepts that I started off with, these levels of representation and really appreciating and understanding how digital information works, but also preparing them for a work environment in which, you know, their employees might be interested in having them do these things. But there is need for adaptation. The existing tools are kind of framed in different ways. They're not as attentive to the structure and persistence of the metadata. Metadata is kind of seen more as an expedient along the way in the forensics world, as opposed to the first class item of reverence that we give it in the kind of library and archives world. Provisions for public access to data. So that's not a priority in digital forensics because the evidence is being used in a much more circumscribed way. And then support for older technology. So floppy disks, zip disks, also older file systems like HFS. And, you know, pretty soon we'll have to be saying this about HFS Plus because it's been pretty systematically, you know, replaced by APFS in a Macintosh environment. This is one of the documents that we've generated from the work that can be useful to introduce students to, from bitstreams to heritage. It was a product, but it was really intended to not be, you know, hey, look at our software, but much more about the considerations, the challenges, and the opportunities in applying digital forensics in these sort of situations. So it in many ways was a natural follow-on to the CLEAR report that many of you have seen that was issued a few years before that. This is just to give you an idea of one of the possible setups, clearly not what everybody's going to have in their settings, but this is a semi-current representation of what our lab space looks like. And this is a place where students can come and work on class projects. You know, we always kind of, when we have classes that have a more forensic focus, we do a little tour and bring them through. So this is not a production environment. This is what we use for our teaching and research. But you can say it has a few different computers. It's got 2 different threads. The one on the left is an older one. The one on the right is a newer one. So when I showed you those images of the different altar bays, those were from these machines. If you look a little more carefully, you can see the these stacks of drives. So we have a lot of, you know, just local storage, many, you know, terabyte, 2 terabyte drives that can be used to just store disk images and things that people are swapping around. We have one of those mini jukeboxes to demonstrate that way of using this technology, where you can plug it into the back of a machine and move it around from place to place so that not every machine has to have the same set of drives. And then just lots of different, you know, write blockers, connectors, old media that we've tried to label as best we could so that it's clear to students what they are. This is Porter Olson's write-up from back in the BitCurator days of a kind of very minimal but descriptive representation of what kinds of adapters and equipment you need to read from some of these older media. And so that's available for people to look at. And then it's worth pointing out also that there are these more kind of, you know, I shouldn't say ad hoc, but just more, you know, pieced together with available technology sort of set up. So this is just one of many. This is from Ben Goldman at Penn State University. So it has a fairly standard commodity machine, but then various adapters and write blockers and things plugged into it. Okay, so on to BitCurator. The BitCurator project concluded back in 2014. So it ran for 3 years in 2 different phases. It was a partnership between Myth at the University of Maryland and SILS at UNC. And the 2 phases were basically, the first one was requirements definition, you know, initial engagement, setup of the software and everything. The second phase involved continuing software development, but also a lot more end user engagement. It's also when we created the BitCurator Consortium, which is the home to the software to this point. So the BitCurator goals were to develop a system for people in collecting institutions that could use these open source tools that would address those issues that I raised earlier: incorporation into their workflows, provision of public access to the data. This is another resource that might be useful for students, not because it really teaches them about the software as much as being a lesson in open source software community development. So in our second phase, the report that we issued was primarily about going from, you know, a project that just developed software to forming a community around the software. And I think it can be really instructive for students who are thinking about, you know, what is the place of open software, open source software in the ecosystem that we're operating in? What are the real considerations involved in making sure that open source software initiatives are successful? What are the cautionary tales? All those sorts of things. So the BitCurator environment itself bundles together a bunch of different things like FiWalk, bulk extractor, Guymager, SleuthKit, all things that I'm about to talk about. It can be run as a self-contained environment. as the operating system of the machine. That is the ideal way to run it, though often in an educational setting, it's just a non-starter because you're not going to have people run a whole dedicated Linux box just for your class. But it is worth emphasizing to them if they're doing it in a virtual machine that there's certain complications and performance sacrifices that you make by running it in a virtual machine, right? So if people are doing this in production, it can make a lot of sense for them to either set up a whole machine or a dedicated partition on a machine and have it run as a Linux environment, because the BitCurator environment is 1804 Ubuntu Linux that's been customized in a variety of ways. So you're actually running a Linux operating system when you're running it. It can be run in VirtualBox and VMware. There are a lot of individual components from it that also can be run separately. And that's something I think is always very important to emphasize, because if you realize in a class that really all you want to use the environment for is to demonstrate identification of personally identifying information by using bulk extractor, you could have students run bulk extractor viewer in a Windows environment and not necessarily use the whole Linux platform, right? It really depends on what it is you're trying to emphasize. The Quick Start Guide is the best place to go for information about. It basically goes through all the tasks we're going to go through. It talks about installation of the environment. It has some information about command line. And at this point, it's pretty detailed. You know, we've been evolving this document over a number of years now. The BitCurator Consortium is the home of the software. So I mentioned that 4 years ago is when the project ended, but the software lives on. And that's because Mellon, to their credit, was quite stringent with us about having a clear sustainability plan, not just, hey, we'll talk about it, but what is our plan actually going to be? We were very fortunate at UNC to be able to establish a partnership with Educopia, who became the nonprofit administrative home of the consortium. That was a huge factor in its success because they already existed as a nonprofit. They already had models for bylaws and all kinds of things that made it possible. And essentially, you know, I know some people on the call are at institutions that are members of the consortium. It used to have charter members in the first phase of its development and general members. We now just have general members because the charter period is done. And to this day, we might have the members decide to change the model, but to this point, it's $2,000 per year per institution. So it's just a flat rate. And I've lost track of the number of institutional members. I think it's 29 or somewhere in that range. They're represented by 4 different countries. We have US, UK, Canada, and Australia, and pretty good possibility of some others coming on pretty soon. Sorry, I see another chat. Oh, a smile. Okay, I'm all for smiles. And so here is, I recognize some people on the call right here in this picture. So this is in front of the Wilson Library at UNC. And this was one of our early events around the project. It has been, just from a personal perspective, one of the most fulfilling things about all of these grants is to really have formed and be sustaining this community, the BitCurator Consortium. We very recently had the user forum in Los Angeles. So this is another sign of its kind of growth and maturity, is that it started out in UNC Chapel Hill, as you would imagine. And the first 2 years, the user forum were right there at the Wilson Library, but then it moved to Northwestern in Illinois, and then it moved to LA. You know, I'm not quite sure where it'll be next year, but it really is a very active community. And so one of the motivations for this BitCuratorEdu project is to figure out a way to make things a little bit easier for people in educational settings to also engage with this group without necessarily having to, you know, go back to the dean of your school and say, hey, we need to pay $2,000 a year or something, right? So one outcome of that could be that we establish some kind of educational membership for the BCC, but there are other models we can be considering too for just, you know, making it more seamless to be participating in this if you're really doing it as an educator and not as somebody who's running the software for your institution in production. So these are the parts of the process supported by the BitCurator environment: acquisition, reporting, redaction, metadata export. And you can see a much more, you know, zoom-inable representation of this diagram on the BitCurator website itself. I've already mentioned getting below the file system by creating a disk image. So in the BitCurator environment, people generally do this with Geimager, not only because it's the primary graphic user interface software for this purpose, which is useful for people who prefer a graphic user interface, but also because Geimager is very powerful. It's a really effective way to create disk images with a variety of settings You can see that the options are either a raw disk image or a forensically packaged disk image. We can talk about that in much more length later on if people are interested in it. It can be a really great thing to address in your classes to kind of, explain the difference between those two and the relative benefits of the two of them. Students will sometimes, really want to have the answer of which one you're supposed to pick, but as with so many things in digital curation, it really comes down to a lot of different factors. We've had fairly hearty debates within the BitCurator Consortium about which scenarios are ones in which people should create packaged disk images versus raw ones, for example. And we will run through the Geimager interface when we bring up the environment, when I bring it up for all of you to see. So scripts, disk image info, show EO1 information. This is an example of a forensically packaged disk image. And one of the fundamental distinctions between a raw disk image and a forensically packaged one is that it has this metadata embedded inside of it. So it has all this information about the acquisition, a hash of the underlying raw disk image content. If you create just a raw disk image using Geimager, it will create a little sidecar file .info that has this information in it, but it won't be embedded in the disk image itself. And the other two primary differences are that they can compress, so you can have a much smaller packaged disk image than a raw one in many cases. And they also have periodic integrity checks built into them, so that if there is corruption in the disk image, you can more easily localize where the corruption is. So there are two ways to interact with disk images. One is by mounting them like regular drives. The support for doing this in the Windows environment has improved over the years. For example, with Windows 8 was when support was introduced for just double clicking on an ISO disk image and being able to mount it. There are dedicated tools like OSF mount in a Windows environment that will allow you to mount a forensically packaged disk image. But the other side is to inspect them as forensic objects, where you use, for example, the disk image access tool in the BitCurator environment, or FTK Imager that many of you have probably made use of before. You're poking down inside of the disk image rather than actually mounting it. So just showing these in the BitCurator environment, this is mounting a forensically packaged disk image. And I'll show how this is done when we bring it up, mount the disk image, and then you see the contents, right? There are relative advantages because mounting is very straightforward. It just looks like a drive now. It behaves just like a drive. You can open the files. It has the disadvantage that you can't see all those little artifacts that you could see if you were looking at it with a forensic tool that will show you, file fragments and remnants of directory entries and things like that. It also introduces the possibility of viruses because the files have now been put into a mounted environment that are treated like files. This is exporting files from a disk image using the disk image access tool. The red entries there are deleted content, so you might be able to recover them, you might not, but at least there's still a directory entry there. And you can do these kind of one-by-one selections, or you can do a more global selection where you'd say, export all of the files in this directory or all the files that have been allocated or haven't been allocated. This is bulk extractor, which scans for personally sensitive and identifiable information. There are a lot of different settings. You can feed it regular expressions. You can tell it stop words that you don't want it to report on. But essentially, and our experience is it's generally most appropriate in most educational settings to just run all the default scanners unless there's something more specific that you're trying to demonstrate. And it looks for geo coordinates, credit card numbers, social security numbers, email addresses, IP addresses, all kinds of things that have been left behind potentially inside files, inside unallocated space on the drive that might be subject to further review. This is the bulk extractor viewer, which you can use to look at. In this example, there's an email histogram. It's showing these email addresses that appear on the drive. Down below where you see where it says privacy at Motorola, those are the individual instances of that email address, and that first orange selected part is the offset. So that's the number of bytes onto the disk where that is found. And then on the right side, you can see what it actually looks like in the context of the bitstream. You could also toggle this over to hex, and then you'd see a hex editor kind of representation of that location. But of course, just having the offset isn't necessarily what people want because they want to know where it is in a file or a folder. And so that can then be revealed by the next set of tools. This is just an example of a dump of social security numbers and date of births that were identified in a PST file that we had been working with. I can say more about later if people want to know this example. So exporting file system content using FiWalk, this is going in and pulling out that information like the timestamps, the file names, and all that information. It also runs a couple other associated operations, including creating hashes of the files and identifying what file type they are based on the magic number. It uses the file utility in Linux to look in and see what kind of file it is. And all of that gets then reported out in the report that we'll look at. Sorry, I just was looking at the note from Cam. So, okay, we'll get to that in a second. There's a lot of provenance metadata that's generated by all of these tools. This is one of the things that most struck me when I first started digging into these things is, you know, we tend to think that archivists care a lot about provenance. We're always obsessed with, you know, like what was the life history of this, what actions were taken. These tools are very obsessive about it, right? So if you look at this, you'll see that it's not just, for example, where it says command line, that is the command that was run. It also tells you what software, what version, how was it compiled, what platform did it run on, what was the starting time of when it ran. So lots of information so that you could go back and say, I got this output on this run, but then when I used a different setting or a different tool, I got this other output, which of course is clearly important from a digital forensics perspective because you want to be able to audit and go back and say, you know, how the information was generated. Then there's also technical metadata, which is information such as, you know, the partition offset, how many sectors are there, how big are the sectors, and all that sort of thing. And then immediately after that is just what are called file objects. And this is the remainder of the DFXML output. This doesn't have to be DFXML. What we're going to look at is an XML output file, but it could be written into a database. It could be output in a variety of different forms. It conforms to this schema called DFXML. And this is file system information. It has the name of the file. It has information like its size, its timestamps. The thing you see down here called a byte run is the offsets of the beginning and end of the file. So most files are written out in sequence on a drive, but if they're fragmented, they're broken up into different places on the drive, there will be multiple byte runs represented here. And then you can also see the hashes of the files. This is the DFXML schema. So, you know, you'll have access to these slides. I mean, you can also just do a search for DFXML schema. It's a pretty distinct string, so you can find it pretty easily. This is maintained by a group. Cam is a member of the maintenance group of this. Alex Nelson, who's been quite active in the BitCurator Consortium activities, is also he's the primary sort of keeper of the schema. What's going on with the tools is basically bulk extractor runs and identifies these sensitive items or potentially sensitive features based on the offset where they are in the disk. FiWalk runs through and finds information about the file system, and then there are various Python scripts and other tools that match these things up and generate various reports, which we'll be looking at. The environment also generates premise event metadata based on a few different, you know, identifiable events that we're able to generate event metadata around. This is another example of something that can be useful to demonstrate a concept that you might be talking about in classes, because, you know, I've found that premise, if you're talking about digital preservation, is certainly an important thing to make students aware of, but it can sometimes be a challenge to identify, you know, good concrete examples of it. Just by running this tool, you'll at least see some of these examples. And then there are various other specialized reports, all of which we'll look at when we run the environment. These are what the specialized reports are, kind of in summary form. So things about the, you know, sort of aggregate level summaries of what the tools have done, information about what file formats were found, that premise metadata that I talked about previously. And then there's lots and lots of other functionality. If you know, quickly identify one of these as I'm scrolling through them, or you look back at the materials later, and have questions about particular ones or find them really compelling for something you want to demonstrate in a class, feel free to let me know. We use them in quite varying degrees, right? So things like read PST, reg ripper that are more specialized, like dealing with email files, dealing with Windows registry. We do use in our full semester, we sort of periodically teach this full semester digital forensics class in which we do a lot of these things. Another example in which I would use some of the more specialized tools is our SAA advanced. So there's that 3-day sequence, fundamentals and then 2 days of advanced. Those 2 full days of advanced afford us the opportunity to really go into a bit more detail in some of these tools. And the motivation for adding them has been that members of the user community have conveyed to us, often through classes, right? A lot of this has actually come through workshops of teaching classes and people saying, I'm really struggling with how to dedupe my files, right? I know how to create hashes, but how would I deduplicate or something? And so, you know, we'll kind of get out there and try to identify a tool that's open source and is robust enough to serve that purpose, and then we'll add it into the environment. If it's not mature enough, because it's more experimental, we have a propensity to leave it out because we don't want it to be a frustrating end user experience for people using kind of, you know, half functional tools. And we also wouldn't add it if it were something that had such a massive footprint. I mean, if you've downloaded the virtual machine, you know that it's like a 4 gig, you know, zip file as it is. We don't want to add some tool in that might have some marginal use to 1 out of 20 people, but adds 5 gig to the size of the virtual machine or something. Also, just to point out, command line operations, you know, if you haven't given this spiel to students before, I certainly recommend it. I know that I do, which is that, you know, there's just a lot of benefit to be had by getting a little bit at least conversant with the command line in terms of stringing different tools together, performing batch operations, changing parameters, because some of these tools have some parameters that you can set only at the command line but can't really set in other ways. And also just there are a lot of tools that are only available as command line tools. And if you insist on always just using a graphic user interface, then that shuts off a lot of possibilities. So I will, before I switch over to the virtual machine and demonstrate a few of these things, I will pause momentarily and see if there are any questions about what we've covered so far. And you could feel free to, you know, either chat or unmute yourself if anybody does have any questions. Right. So, so for those who didn't see it in the chat, Howard was saying how at NYU they have people use VirtualBox so that they can, you know, run a variety of other utilities. And I agree, that's really, really beneficial because it then opens up the possibility for them to, you know, run an entire environment that would otherwise be a big hassle for them to try to get set up somewhere just by, you know, running it as a virtual machine. So what I'm going to do here, oh, I don't know that, let's see. If I go to stop share and then sorry, I'm going to share again so I get it to the right application. So hopefully everyone should see this. Shout at me if you don't see it. So this is VirtualBox, and what I wanted to do is run through a few of the setting things that can be both helpful to show to students, but also just good for you to know when you're administering it. Is that it? Okay. Oh, Kim also saying having students use VirtualBox. Yes. I mean, yeah. Thank you for pointing that out, because it is really, even if you're not using the BitCurator environment, right? Just the possibility of being able to run some other platform on your computer is powerful, and it also means you don't have to know as much about every student's own machine. As long as they've got a machine that's powerful enough to run VirtualBox, it kind of becomes less of your problem how they administer it, right? And so if you go to, you know, if you were to have gone through the process of installing VirtualBox, going to adding the virtual machine, you can then go to settings. And this is one thing that's very important for students to know about, is that because they're likely to be using it on a lot of different hardware, right? You don't know precisely what kind of machine they're going to be using necessarily. You do want to tell them the basic specs, because, you know, if students are trying to use a machine that has 2 gig of RAM or something, right, it's just not going to work. But they can go into these system settings and then slide the slider up to the top of the green range so that it's allowing the virtual machine to use as much of their host computer's processor as possible without, memory and processor without like overtaxing the host computer, right? So there's the guest, which is the BitCurator environment in this case. It's the virtual machine. The host is the environment that they're running it on top of. And what you want to do is make sure that both for the CPU cores and the processor, and the memory, that you have enough given over to the virtual machine that it doesn't run painfully slow, right? So it's one of the kind of troubleshooting things to be aware of. If you have a student who's running into, oh, it's constantly crashing, I just can't get it. I sat there and I clicked on something and it's hanging for 10 minutes. It's possible that they need to shut down the machine. You can't make this change while the virtual machine is running. And then adjust these so that it's giving it enough kind of power. Another thing to be aware of is shared folders. So if you go into shared folders and you click on the plus here, you navigate to the location on your drive, go to your desktop, wherever it is. I generally go to a folder that I have set up that's just called forensic disk images. Then when you say auto mount, well, I guess I'll pick one so that you'll actually see this in action. So it doesn't particularly matter what I pick. I will just pick my desktop, select folder, and then you have to make sure to say auto mount and then okay. So what I'm going to do, and again, I know many of you are familiar with this environment, so I'm really going to do the very quick walkthrough. I'm not going to go through all the functionality of the environment. I just want to demonstrate those basic running, the bulk extractor and the reporting tools, and then I want to make sure we have sufficient time for discussion if people have questions about any of that. So if I double click on it, I will power it up, and it's going to take a little bit of time to start up because it's loading a lot into memory. It's basically bringing up this Linux environment. This is just the bootloader. You can either just wait for it or click on enter when it comes up. I'm using the latest VM that's available for download right now, which is 2.06. That's based on 1804 Linux. So it's the latest long-term release of Linux. One of the shifts we went through over the past few months is going from 1604 to 1804, which some of it just seems cosmetic, but there are some underlying issues in terms of how the different software runs that needed to be resolved when moving to the new environment. So if you see anything or you ever run one of the machines that's before version 2.0 or later, it means it's running on that earlier version of Ubuntu Linux. And I think I did see, was there a chat thing? While this is coming up, I was just going to see. Okay. I think those were the ones I had already seen. Okay, so it's here, right? And so what I did, just to very quickly show you, if you're not familiar with it, I had gone to a website called digitalcorpora.org. So you can do this, there are two primary ways to do this. You can either have students get files from somewhere, put them on their host machine in a folder that then is shared as a shared folder, and they can just pull it out of that folder onto their machine. The other way is to just have them go download something. And one thing that we do, particularly for shorter things where you're doing a 1 or 2 hour segment on the BitCurator environment in a class that's covering lots of other things, we will have them use one of these M57 dataset items. So this is just digitalcorpora.org, and then if you go to that website, you go to scenarios, there's M57 patent scenario, and then there are full hard drive images, but then also USB images. And so, for example, in both our electronic records class and when we do the full on digital forensics class, we have the students use a combination of disk images from other places and also a full hard drive image, because it just gives them much more possibility to look for email and traces of operating system activity and all kinds of stuff. For a shorter segment of a class, it just takes a lot more time to process anything on a full drive image, so it's much more straightforward to use a USB drive. So we've got these USB drive images. I've clicked on Joe Work USB and downloaded it to the desktop. Just as a reminder, the shared folder that we set up will appear on the desktop. It says SF_desktop. So if I were to click on here, I can see anything that's sitting on my desktop, which looks a little bit messy at the moment. So we'll avert our eyes from that. And so what I want to just show you is, first of all, if we right click and I say scripts, disk image mount, I can then mount the disk image. And now if I go into it, I see the content. So that's what I had demonstrated to you before. And I could also look at the, the disk image information and see the embedded metadata within it. This is a good lesson for students. You can run, we often do this in class where we say, you know, what does this hash represent? And then we are emphasizing this point that the hash sitting inside of the forensically packaged disk image is the hash of the raw disk image data and not the full package itself. So you can have them run a checksum against that full container file and then compare it to this one. And it's guaranteed to always be different because they're two different things, right? One is the underlying content and the other is the full package. So what I'm going to do is just go to forensics and reporting. If I go to the BitCurator reporting tool here, the first thing it will prompt me for when I bring it up is you should run bulk extractor, right? So I could have just run bulk extractor first, but I brought it up here. It'll launch the bulk extractor viewer. I'm going to go to tool, and I'm going to run through this very quickly because first of all, I know some of you are already familiar with these things, and second of all of these steps are covered in the quick start guide. I really want to just show you the steps and then talk a little bit about what I think the implications are for teaching these things, right? So you go to run bulk extractor, you identify the image file. So I'm going to go to the desktop and find that disk image file and say, okay, I'm going to go to where I want the output from bulk extractor to go. So I'll go to the desktop and I'll create a new folder and I'll call it BE out. Then I have to navigate, and this is a little trick that you want to make sure you kind of pause and walk students through if you're doing this live with them, is to make sure that they select BE out and then say select. If they don't go through that extra step, it's going to, by default, drop everything onto the desktop. All the functionality will still work. It'll just be really ugly because it drops a bunch of these files onto the desktop rather than into a dedicated directory. So once again, all of these different settings are things that you can cover in more detail if you have a more advanced class, but I'm just going to submit the run. It's going to, this is the command that someone would have issued if they'd run it in the command line. And it should run pretty soon here. So you can see the progress. And when it completes, we'll have a little report here on the left side called BE out, where it will show the output. And the output is essentially viewing into some underlying text files that are very, very simple. The text files just have offset, which means that, you know, the number of bytes onto the disk, the feature, which is the thing that it found, like it thinks it's a phone number or a credit card number, and then the context, which shows you 16 bytes on either side of it. So this has successfully run. If I go in here, I can look at the different things. Like, for example, here's email addresses. I could go to a particular email address and it's going to show me in context where that is, right? So the next thing generally that people will want to do is then say, okay, I've run bulk extractor. Now I want to run these other reports. So I'll go to the desktop. I'll select again the disk image that this is based on. I'll tell it where my bulk extractor output is. Keeping in mind also that if people are doing this in production, if they're doing this on a very large number of disk images, for example, it can be beneficial for them to write a script rather than having to click each time in all of these different places, right? We can't hard code in where these things are located because we don't know where people have their storage set up. So the default behavior is you have to do this clicking, right? So then I'm going to create the output for the BitCurator reports. I'll just call them BC reports. Say save. And now you can confirm that it's the disk image, where the bulk extractor output, and where the reports are going to go. And then I'm going to run it. It's got the nice little Knight Rider activity going on here. And then it's going to dump all of those reports out to this BitCurator report. Oh, did I put it in my home directory? Maybe I didn't put it on the desktop. Yeah, I accidentally put it into the home directory instead of on the desktop of the home directory.
Hey, Cal.
Yep.
We have a frozen screen issue.
Oh, really? Oh, you can't see what I'm doing?
We can see the VirtualBox manager interface. Perhaps you need to, well, I'm not sure.
Okay, so what, you're not seeing the virtual machine, you're seeing?
We're seeing the VirtualBox manager interface.
Okay, has that been the case the whole time?
Yes.
Oh, great, okay. So this has been, shall we say, deeply unsatisfying. Okay, I'm not quite sure. I'll try stopping sharing and then share again. Okay, do people see that?
Yeah, it's good now.
Okay, all right, so my apologies. So I'll just, since you didn't see this, right, I ran the bulk extractor tool. It generated this output, which is these text files that just have offset feature context. This wonkiness is because these are escaped Unicode. They view as just text if you open them in the bulk extractor viewer. So offset feature context. We looked at it in the bulk, I looked at it and you apparently didn't, in the bulk extractor viewer. And now we're just looking at these other reports that got generated. So for example, here's the FIWALK output. It shows the those things that we had run through, the kind of more technical metadata, and then just lots and lots of these file objects. The file objects have the file system information like, you know, you can see here the name of the file, how big the file is, what the timestamps are, whether it has more than 1 byte run, what the hashes of the file are. Then these other reports. So the reports are a table of what formats are represented, a little bar graph of the formats so you can kind of get a distribution of them, the premise metadata that we looked at before, the FIWALK output report, which summarizes what kinds of files it found. There's a FIWALK output that is a spreadsheet, just because that's much easier to kind of navigate, sort, search over for a lot of different purposes. So it's essentially a subset of the data that was available as XML that we just looked at before. And then the features here are the offset, the feature, and then the file name that it's located in. So that's with that matching up that will then tell you where it actually is in the file system. And I'd be happy to run back through the initial interfaces if anybody wants me to, because I realize that you apparently didn't see any of those. But that's essentially what I wanted to demonstrate and see if anybody had questions or comments about how they've been using these things. You know, the benefit of it being this Linux environment with all these different tools installed is that there are a lot of different things for class purposes that could be demonstrated in the environment. But if the primary purpose is to show how it's being used in library archive settings, the default in our teaching tends to be to run through, you know, putting a disk image into the environment, mounting the disk image, seeing the contents, and then also running bulk extractor and these various reports, because that's what a lot of the users of the software are doing for most of their collections. So what questions does everybody have? And I'm sorry that I missed that. If there was a note about you not seeing the environment. So I'm going to go to the chat, but people can also just jump in. I believe you can probably unmute yourself.
Hey Kyle, this is Devin Donaldson. What was the setting that you said has to be checked so that it won't like all download to your desktop or something?
Oh, sure. Yeah. So let me just show you that very briefly again. And again, I'm really sorry that I didn't realize that you weren't seeing that. I mean, it only took me a couple minutes, right? So I can very easily just show that to you again. If you go to the forensics and reporting, whoops, oh, I've already got it open, sorry. And you go to the BitCurator reporting tool. What I did is I first launched bulk extractor viewer, and then I went to run bulk extractor, and then just told bulk extractor, where is the disk image, right? So you navigate to it and select it, desktop, pick the disk image, say okay. I selected where I wanted the output to go. So I had created a folder called BEOut. And this is where I was saying the trick is. You go and you create a new folder, and then the next step you want to take is scroll down to where that folder is and select it. Because if you don't do that, then it's just going to go to that desktop and take all of those little text files and drop them onto the desktop. And you'll know if you've done that right, because if you say select, then you'll look here and you'll see the path, and it won't just be BC Admin Desktop, it'll be BC Admin Desktop and then whatever the folder name is that you've created. Again, it's not like a showstopper, it'll still run, it just ends up being kind of messy because there's all this stuff all over the desktop. And it certainly could be an issue if you were running this over and over on a bunch of different like, you know, disk images, because you wouldn't want all the output to be dropped into the exact same location. And then you would just submit run. And when I did that, that's where I got this output. This is showing the output, you know, domain names, email addresses, whatever they happen to be, and then in context. And then that final step that I ran was to go back to the reporting tool, tell it where the image file is, tell it where the bulk extractor output is that I had generated, and then tell it where I want the other output to go, right? Where do I want my BC reports to go? So I had called it BC reports and said save, and then just ran it, right? Which is those couple little steps that I think everybody missed because I wasn't showing them. So again, questions or observations, thoughts about having done any of this in classes?
That was great. Thank you, Cal.
Okay, and I will say again, these things are all in the quick start guide that you can kind of run through. And also, if there are things that are more related to, you know, how you would administer this locally, what kinds of tech support issues there are, feel free to share them now, but also be aware that we're going to have a whole webinar on that topic itself. So we hope you can join us for that, and, you know, hopefully have somebody from your own institution join it as well if they're available to, you know, get an idea of what it means to actually do some of these things in classes.
Hey Cal, this is Michael Wilson.
Yep.
I've got one question, and that's about you talked about the Corpa, the digital Corpa that
Yeah. Yep.
you're teaching. Has there been discussion about kind of creating a set of resources for libraries and archives that would have specific use cases that one could use for teaching purposes?
Yeah, it's a great question, Michael. And so just as a reminder, I'll bring this back up again. So the digital corpora, right? Then you go to corpora, there's scenarios. The M57 patent scenario is the one we tend to use the most because it was created for a similar kind of purpose. I mean, it's for forensics education, but, and Cam was actually very heavily involved in the kind of dissemination and documentation of that data set because we entered that project after Simpson Garfinkel had started it with NSF funding. The short answer to it is that we tried to do exactly that. We partnered with Simpson. We put in an NSF proposal that was specifically to do generation of forensic data for education that was more specific to like a cultural heritage kind of setting where there might be, let's say you're in a university setting, there might be, you know, human subjects data from research, there might be student records, there might be things like that. And it just didn't get funded, and we haven't tried to pursue it again. But I think it would be really beneficial. The question would be, is it very viable outside of the scope of a project? Because it was a lot of effort of this team at the Naval Postgraduate School when they developed this data set. You know, setting up the machines, running them in kind of a clean room environment to the degree they could to make sure that they only left the artifacts that they wanted to leave on the machines. So I think it's a great question, Michael, and I know that we're still very interested in pursuing it. I don't want everything to be turning into a grant proposal necessarily, but it does seem like something that if we collectively wanted to do that, it might be warranted to try to put out a proposal for doing it, because, you know, hiring some people to generate the data based on following scripts and creating files and stuff is really what made it such a rich resource in this original case, in the M57 patent scenario. You know, so it has things that are constructive for a library archives kind of setting, because you also need to be making inferences about who was using the computer and, you know, what files they were creating. But it's based on this notion that you're peeking into this company that had a bunch of bad actors in it, right? You're trying to figure out who deleted the files and who sent the email and things like that, which in itself isn't really our primary scenario, right? We might be more interested in, you know, here's a disk from somebody that shows evidence of online activities that might let us know, you know, what else we'd want to ask the donor about in terms of where their files might be located or something, right? We haven't done that to this point because we didn't get funded.
No, but that's really useful to hear. Actually, I didn't know the background story behind this particular use case.
Yeah. So
actually, that's the one that I actually chose to teach with. So so that's really helpful. Thanks.
Yeah, another thing you might not be aware of, if you poke into the materials, you can see that there's actually an answer key. There's like, you know, like questions and an answer key that's encrypted that you have to request the key from to open it up. So the idea is that, you know, only instructors would get the answer key. So, and that again, I mean, Cam can speak more to that because that was actually his initial position when coming to UNC was as a postdoctoral fellow on that project, developing that data set. And so it's got a lot of thinking behind it, right? Of like, it's got all these different characters of Charlie and Pat and Joe, and they do various, because it's a 2-week sequence of activities that the data is based on. But, you know, to answer your initial question, Michael, yes, I think it would be very beneficial still to try to pursue creating some shared, because the challenge is to make something that's both instructive, like really reflects what data would be like, but isn't actually sensitive, right? Because what you had previous to this was 2 sides of the scenario. One is you have students launch in and start looking at their own devices, and that could be problematic because they might unearth things that they shouldn't be sharing with other people. The alternative is you go to these ones that have been often created by like software vendors or for other purposes where somebody's created a very, very specialized disk image that just shows like somebody penetrating into a network or something, right? So it's just got a very, very contrived sequence of events that you can detect on the drive, but it doesn't necessarily have the traces left behind over days and days and days of activity the way you would actually expect to find on a disk, right? So creating more things like that would be really beneficial. There is another one that Simpson just recently, like a few weeks ago, I believe, maybe it was a month ago, another scenario, the, help me, is it the, Cam could tell me probably, I'm trying to remember what it was called, but there's another scenario that they just recently, is it the Gene? Maybe, no, it's not Gene. Anyway, it's one of these other scenarios that they had been working on for a while and just recently released as well. But as you'd guess, they tend to have a focus on kind of law enforcement kind of scenarios, right? Somebody did some terrible thing and now you're trying to figure out how to, you know, retrace their steps. And I would say also that if people come up with their own test data that they find useful in their classes, you know, it would be great to try to figure out some ways to share those that's lightweight enough that, you know, we're not creating some big formal registry that takes months of development, but just a place to share them. Because, you know, it's work. Like if you go in and you create a, you know, a disk image with a bunch of example files of different types because they demonstrate different ideas you want to show in your class or something, being able to then share those is really beneficial because then maybe somebody else doesn't have to do all that same prep work. Yeah, so Cam's providing a little bit more commentary about the corpus. I mean, another thing is to have, because, you know, within the scope of this project is both university, you know, kind of graduate and undergraduate education, but also continuing ed is one of the things that we've done in a few classes, but not very often because it's messier. But, you know, I have done it in a couple classes in the past couple of years. Porter Olson did a lot more of it when he was the community lead, going out and working with partners, which was they would bring their own data, right? So not their own, meaning like from home, but their own data from their own collections. And so, I mean, that can be useful if you have enough time to really get to it. Of course, it introduced more variables. You have to be much more willing to admit defeat if somebody brings something in and you just can't get the data off of it or something. But in some situations, that can be really, really compelling to people if they come in for, you know, a workshop for a day or two. You've done some introductory coverage of the functionality, and then they say, you know, well, here's the disk I brought, right? But then it does have the hardware dependencies, right? You have to figure out whether you're going to also bring in a bunch of, you know, floppy drives or whatever it is.
So Cal, this is
Yep.
Devin.
Yep.
I'm at an institution where I haven't actually had the students interact with it. I've told them about it. I've shared with them screenshots. But do you have any tips or advice for, I mean, as I was going through this and listening to this, I was like, I could just imagine some of my students being like, you know, like,
Right.
wait, hold on, wait, you know. Do you have any tips for like how to teach this to students that would have more of the limited knowledge?
Sure, yeah, yeah. And this is probably, we've hit the top of the time, so this is probably the last question. And it's a great question, Devin. And this sounds very trivial, but one thing that I've found is really useful is rather than, okay, you know, like 1, 2, 3, go, and then you just have them do a task and you wait for them to be done, is to actually walk through the task with them step by step by step, right? So that if somebody falls behind, they don't feel like they've completely lost the opportunity to participate at all. You know, it can be a little bit frustrating to people who are more advanced because they're kind of watching you and waiting through as you're doing it really slowly and methodically. But I've found, because we do this a lot for the SAA workshops, like a lot of the people in those classes have very little previous exposure. And you can really keep the whole room up with you as long as you make sure that, you know, you're just like, okay, is everybody with me? Did anybody fall behind? And you just make sure you really don't take anything for granted, right? How to open files and folders and everything. It can help to have a team also, right? If you've got somebody else who can help out, it could be, you know, a grad student who's had a little bit more experience who can kind of work the room as well. But well, again, we've hit 2:30. Thank you very much for everybody. If you have additional questions or thoughts, feel free to share them with the project team because we'll have opportunities to address them further. And I hope this was helpful. Sorry for the little mishap once we got the screen sharing up and working. I think it was hopefully clear enough to everybody.
Thank you so much, Cal, and I hope everyone has enjoyed. Please do get in touch with Cal and me with any questions that you may have following the workshop.
And we hope that you'll be joining us for the next two, because we'll be covering a lot of the software that's newer and then also more of the sort of tech support implications of all this.
Take care, everybody.